In this video, I'm going to show you how I diagnosed a bad fuel level gauge in a boat. I'll show you the classic circuit design of a typical marine fuel level sending unit and gauge, and I'll demonstrate the use of a few diagnostic tools you may not be familiar with. Good morning. Well, the last few weeks I've been getting wonky readings from my marine fuel tank level sensor. Let's see if we can fix it. Of course, the first challenge is to try and decide where the problem is, be it in the gauge, the sending unit, or the wires between the two. To do that, you need to understand how these little systems work. Fortunately, the design is elegantly simple. Power comes in here at the terminal in the back of the gauge labeled I for ignition. From there it goes through the first coil inside the gauge that produces a magnetic field. Coming out of the coil, electrons come to a Y intersection. From there, current can either go this way through a second coil inside the gauge, then to ground, after that through the G post in the back of the gauge. Or electrons can pass through the Y to the S post, and then along a wire that leads to the sending unit with its variable resistor, and then to ground after that. Now here's the thing. Inside the gauge is a magnetized needle that moves depending on a tug-of-war between the magnetic fields of these two coils. If the resistance to the sending unit is low, then little current flows through the second coil, and the needle points to full. But if resistance of the sending unit is high, then most of the current goes through the second coil, and the needle points to empty. Does that make sense? Inside the tank, the sending unit has a float that rides on the surface of the fuel. So when the fuel level falls, the arm attached to the float moves downward. The arm of that float is attached to a variable resistor, sometimes called a rheostat or potentiometer. The resistance of that device varies depending on the position of the arm, with higher resistance seen in an empty tank. Now, the design of these marine sensors can vary, but typically they show a resistance of about 30 ohms with a full tank and about 190 ohms with an empty tank. Herein lies one of the pitfalls you can run into. Your sending unit and gauge need to be matched to the same scale and in the same direction. So if yours has an unusual design, it may not be as simple as swapping out the part as bad. You might need to replace both as a complete unit. All right, to do this diagnosis, I'm going to use the old Power Probe 2. And this is a nifty device used in automotive diagnostics, and it's very useful in boat diagnostics as well. Now, the way this thing works is that it's got about 30 feet of cable, and you hook up the positive lead to the positive pole of the battery, and of course the negative lead to the negative pole, and so you don't have to be hunting around for a good ground and wondering if your ground is good. Now, this is used for continuity testing. You can tell if something's confluent with ground. So, for instance, here, I get a green light and I get a 0 reading on this little voltmeter that's inside of it, and it gives a different tone if I touch the positive pole, and it reads 13.7 volts there. Now, the cool thing about this power probe is that you can actually apply voltage as well. So if I press this button, I'm applying 13.7 volts to the tip of that lead, and similarly I can apply a ground, and so I can test sensors and test devices without concerning myself as to whether my diagnostic tool has a good ground. So here we are at the sending unit, and this is the power, and that's ground. And I've got the key off, engine off at the moment. And so I want to ask you a question. Before we actually test this, I want you to tell me, by looking at the circuit diagram, what do you think that the power probe is going to tell us about these two connections here? Is it going to be 0 volts? Is it going to be 12 volts? What's it going to be? So you can pause the video for a second and think about it if you want to, but here goes. We get a green light and it's 0 volts. Is that what you expected? Now let's look on the ground side. And of course the ground side is 0 as well. So that looks like it's normal. Now my next step is to check the wiring. We know from that the ground wire, this black wire, is good. But what about this red wire? Now to test that, there are a couple of different ways of doing it. But what I'd like to do first off is I'd like to apply power to the gauge. And there should be power coming down here. And we should be able to measure that with the power probe. So I'm going to go and turn the engine on. Turn the ignition on and come back and measure that. Sorry, it's a bit noisy. Let's see what it shows. 4.6 volts here. Ground is still ground. Now that's pretty good evidence to say that this wire is working properly as well. Let's do another test of that same issue. So as one final test to see if the wires are okay, I've disconnected the sending unit entirely, and I've got it instead I've got it hooked up to this test light. Now I'm going to fire up the engine, and we'll see if current can carry enough current to make this test light glow. Let's have a look. I'm not sure if you can see it, but I've got some light there on the test light. It's not glowing very hot, but it's good enough to say that these wires are okay. They don't have to carry very much current. So now let's go on to testing the sending unit itself. So now let's have a closer look at the sending unit itself. I'm not sure if you can see it, but there's a scale here that reads from empty all the way to full, and according to this scale, we're at about half full. So what I want to do now is I want to check for continuity between the two posts of the sending unit. So I'm just going to do this here. Got the multimeter set to ohms, and I read 122.3 ohms, which is about what you'd expect for a tank that's half full. So this seems to be good. Now, this sending unit has an arm on it that moves, and to test it properly, you'd have to undo all these screws, lift it all out, and swing the arm through its range of motion and see if the resistance varies. But from what I can see with non-invasive testing, this seems to be okay. So let's move on now to look closer at the gauge. The first thing I did was take a quick video of the back of the gauge with my phone so that I wouldn't make a mistake when hooking it all back up again. This is critical if you do things yourself, because if you make a mistake here, it can take professional hours to retrace your error. The cleanest way to test a gauge is to do it on the bench, so let's disconnect everything and take it home. So here you are on the bench. I've mocked up a reproduction of the circuit drawing using a simple resistor right here in place of the sending unit and a bench power supply here set at 12.2 volts. I've set up my multimeter to read inline current, presently at 62 milliamps right now. So here's a closer look at the connections on the back. I hope you can see this. I is where the power goes in for ignition, G is the ground connection, and S is the signal wire that goes to the sending unit. Now it's critically important that you never put 12 volts to this signal wire, because if you do, you could fry the coil downstream. There isn't enough resistance from that point on to limit the current, and the coil ends up getting fried if you do that. Now look at this coil. This is the bad coil, and you can see that with a 100 ohm resistor in place, we're well over full, which is way too high. So here are the connections with a replacement gauge I got from Trotac Marine for about $35. I is power in, ground is G, and S is the sensor wire. And you can see we're drawing about 72 milliamps. And with that, if I just carefully turn this over, the gauge is reading half full. So that's more appropriate to what we're looking for. Let's make a table with different resistances and see what we get out. All right, well, not to beat this dog to death, but basically I made a set of tables looking at various resistors that I put in place of the sending unit, and I measured the current draw and what the gauge showed on the front of the gauge. And I did that with the old gauge and with a new gauge that I bought at Trotac here. And you can see that the new gauge is giving much more appropriate readings. I've clearly shown that the old gauge is bad, and it's now time to swap it out. All right, now let's put in the new fuel sensor. It just pushes in like this. Fortunately, the fit is pretty good. I've got a 2-inch O-ring and I'm going to put on the back to make it seal properly. Now the way these work is they've got a flange that goes on the back, and so from the back I'm just going to push this on and then bolt it together. Incidentally, this little thing here is a light bulb, and you can change it easily enough. It's incandescent, strangely. It's too bad it's not LED, but in any case it's low current usage, and if you want to change it, you just pop that thing out. So there we are. I hope this video helped you out. Thanks for watching.